All right, in this video, we're looking at the physics of waves, and these are questions that actually come from 2019, the winter administration, in October, November, paper 13. So question 21 reads, which statement about light waves and sound waves is not correct? All right, so we're listening for the not correct information. Light waves and sound waves can both demonstrate the Doppler effect. Well, that is correct. Light waves are transverse waves and sound waves are longitudinal waves. That's also correct. Light waves can be diffracted, but sound waves cannot. Well, that's not correct. Any wave can be diffracted. So C is the correct answer to this, which means that D is a correct statement. Light waves can travel in a vacuum, but sound waves cannot. So sound waves, the longitudinal sound waves, need a medium to crash into. The light waves can go through the vacuum of empty space. C is the correct answer to question number 21. Moving right along to question 22, you can see it displayed. The question reads, the graph represents a sound wave. Which statement is correct? The wave is longitudinal and has a period of 25 milliseconds. Because they're telling us it's a sound wave, it is true that the wave is longitudinal. Sound waves are longitudinal. We just read that information a moment ago. And so C and D will discard as incorrect answers. Now the period is 20 milliseconds. We can see from trough to trough, the period is 20 milliseconds, and so it's not 25. So it must be a longitudinal wave that has a frequency of 50 hertz. You can prove to yourself that the frequency is 50 hertz by taking 1 over the time period. Remember the time period, we can read off this graph as 20 milliseconds. So 1 over 20 times 10 to the negative 3 is indeed 50. So there you have it. Choice B for question 22. This has been 2 paper 1 waves questions with Dr. Schleich, and we'll see you shortly for the next video.